workshop here on the technical underpinnings of the Bluzelle database by our resident developer / researcher, Isabelle. Isabelle is a bright bulb. Every time that she speaks, my mind gets blown. She's used to work at NASA as well as at Amazon, and she helps our CTO Neeraj to look at the technical roadmap and ask him questions about why hasn't he thought of these other things, and give him a stress. Anyway, this is going to be a great presentation. I'm glad you guys are here to listen to it. I guarantee you're all going to learn something really cool about Bluzelle, at least one thing. So here we go, Isabelle. Thank you.
Thank you. Okay, so I want to talk a little bit to explain what I'm going to do here. I want this to be very informal. I've got some prepared remarks, but I want it to feel like a conversation. So if you have any questions, objections with what I'm saying, something you don't understand, or something you don't believe me about, I'd much rather get into an interesting conversation than spend the whole time on my prepared remarks. So please don't hesitate to ask any questions. The other thing is that I'm going to lose my voice before the end of the day. It just happens to me, so please bear with me. I'm going to try and speak loudly and clearly, but please have patience. So what I'm going to do is first I'm going to talk a little bit about what Bluzelle is, and obviously you wouldn't be here if you didn't know that to some extent, but I want to make sure everyone understands the design goals that the technical discussion needs to support, and I want to make sure everyone has the same vision on that. And then I'm going to go in more detail about how we accomplish those things. So as to what Bluzelle is exactly, so two aspects to this. The first is what we are providing as a company, and the second is why you would want to use our product. So to the first point, consider that we have an internet, which is a way that all of our different computers, things that are like computers, can talk to each other and work together to accomplish things. And in practice, we don't do that. We have my phone talks to Amazon, and your phone talks to Amazon or Microsoft or whoever is your cloud provider of choice. And then their server does all the things and then delivers the response. And we're not actually using the network. We're not actually using your device's resources to accomplish any useful part of the work for most applications. We're just using it to display content. So what if we could change that? What if we could have those devices meaningfully work together to accomplish the result? That is what we're trying to do for storage. Our idea is that you've got devices that have spare storage, whether they're your desktop, your laptop, your phone, your toaster these days. You can lend that storage out to the network. The network will store things on your device. It will pay you in some sort of crypto economic payment for it. And the people who are storing the things will be the ones paying you. Now, as for why you would want to use that storage, beyond the noble goal of all the devices working together, why is that actually valuable to you compared to other storage solutions? The way I like to put it is that we are a scalable, trustless, decentralized database. And I want to go in a little bit to what I mean by each of those. So when I say database, I mean we're abstracting away everything that you would have to care about that is at a lower level than just this is the data at a lower level than a key value store. We are giving you, the back end is widely replicated, it is reliable such that if one hard drive fails, the data will be retrieved from somewhere else seamlessly, and you don't have to worry about any of that. You don't have to worry about where it lives physically, you don't have to worry about how many copies of it, you don't have to worry about how you're breaking it up across hosts and so on. We're just providing a minimally simple, this is the key and this is the value associated with the key. I got a bit ahead of myself. By scalable, I mean we can efficiently handle a very large volume of data. And that's not really a good explanation. I mean, we can efficiently increase the volume of data we can handle by adding more computational resources. The contrast is that, for example, if you're using a single instance of MySQL, then you can increase the data you can store and the transaction throughput by running it on faster hardware, but eventually becomes exponentially more expensive to keep buying faster hardware, and you start having to scale it out to multiple instances, and so on. What I mean is that we can efficiently scale up to a very large volume of data, a very large throughput of data. By decentralized, I mean that there is no key, there's no key element of our architecture that must continue operating for your data to be available to continue using the database. So in the example of a single MySQL instance, anytime that server fails, your data is no longer available. If you then scale that out to have multiple instances that are such, one is a backup, or several are backups, and one of them is the live ones, that when the live one goes down, you can hit the backups, then that removes that point of failure, but you often still have some sort of central load balancer or some central entity that is coordinating those or synchronizing their versions, something like that. And architecting your storage system to not depend on any such central element is difficult. So what I mean by decentralized is there is no single element of Bluzelle that is not replaceable. We design for nodes to fail frequently and randomly. And then finally, what is the most novel, I guess, is trustless. And by that I mean we're not asking you to trust the honest behavior of any participant in the system, even us. If you consider a classic Android app, say, so in a classic Android app that is, somehow storing your data on some cloud service, the details aren't important. In the most naive version, we're trusting the application itself to not mishandle your data, expose it to malicious things with it. You're trusting the ISP to not do the same. And you're trusting the cloud service, AWS, or I use AWS just because that's what I'm used to, but I mean any sort of infrastructure as a service provider for that. In the most naive version, you're trusting all of these entities to behave the way they say they do. And you can, you can mostly cross this out with cryptography, such that the ISP probably can't see your data, can't selectively interfere with it. But this you can mostly cross out with open source, which we are. We provide our source code. We're not trusting you that we do what we say we do. There's no server that you do not see the source of. But this is the single one that is still difficult to avoid trusting in a cloud architecture. Because although with encryption they can't see what your data is, they can still suppose that, and if Amazon wanted to see what your data is, they probably wouldn't, because the reputation is worth more than they could possibly steal from any individual customer. But that said, if your app were to become politically unpopular or illegal, Amazon might choose to stop doing business with you at any time, and you have no real recourse against that. By trustless, I mean that there is no box left here that you have to trust. And the network continues to operate regardless of the behavior of any individual actor. Okay.
Do you want to add a bottle of water?
I have one over. Okay, so that's my summary of what we are trying to provide. Does anyone have any questions there before we go into how we do it? Okay. So all of our marketing literature uses the term swarm of swarms to describe our architecture. And while that's true, I find that the best way to the way I like to explain it technically is the slightly less true, but fancier sounding, distributed hash table of blockchains. And to explain what I mean by that, I want to spend a bit of time discussing what a distributed hash table is exactly and what a blockchain is in the abstract. So as a reminder, okay, So distributed hash table is as a reminder, those are the goals that we're seeking to implement here. A distributed hash table is an algorithm by which multiple devices can work together to be a database, basically. Suppose we're a covert file sharing operation and we all have these illicit files that we want to share with each other, and we're going to have our devices work together to offer this interface where anyone can look up any of these files. The algorithm will figure out what device that file resides on, connect you to that device, and then you can download the file. The classic distributed hash table algorithm is called CORD. And the core abstraction of CORD is the idea that conceptually we'll draw a circle. And we'll define the circle to map to the interval from 0 to 1. So like 0, 1, 0.5, just a circular coordinate system. And we will, for each object that we want to store, say our objects are alpha, beta, and delta. Alpha, beta, and delta. We'll take their hashes using some arbitrary hash function. And we'll map those hashes to the interval from 0 to 1. And for the sake of argument, let's say that we get something that's like 0.3, 0.9, and 0.1. So with
you're running a true mod just so everyone knows, right?
What's that?
You're modding it. I mean, like you're doing it from 0 to 1, but probably it's going to be up to some integers, and then you can take the mod of that.
Sure, like we can use any mapping from the actual domain of the hash function to 0 to 1.
Yeah.
We can like, if this gives us a 256-bit integer, we can.
If you have four nodes, for example, you can take mod 4, and they would map it to them.
We're not doing that actually. Okay. That's the key.
Sorry, if you could repeat his question for the mic, because the people on
the
Twitter.
question was, so like if we naively wanted to distribute some range, say the output of a hash function, amongst nodes, and we had 4 nodes, we could take the value we got, which is some integer mod 4, that would give us 0, 1, 2, or 3, and that would tell us which node we wanted to store it on. We are not doing that.
Okay.
Not doing that is the reason we have this circle concept.
Why are you not doing that?
Because, so say we stored each of them on 1, 2, or on 0, 1, 2, or 3, and then a 5th node joins, and now it's mod 5, most of the keys have to move.
So are you using virtual nodes? No. I mean, like React, I think.
We're not actually using CORD at all. This is just me explaining the concept of distributed hash table. Okay. So in some arbitrary deterministic way, we map the hash values of our 3 objects, alpha, beta, and delta, to the interval 0, 1. And using my choices there, that puts delta at like there, beta at like there, and alpha there. Okay. So that gives us locations on the circle for each of these data elements. And then suppose we also have, say, only 2 nodes, and our nodes will be A and B. So for each node, we will also hash that node's identifier, which can be a unique address or like a UUID like we're using in Bluzelle, or it can be an IP address, just something that is unique that identifies that node. And that node is also mapped to a position on the circle. So here we've put A here and B here. And then this gives us a mapping of which data items are stored on each node. We define that. So from here, because A is at 0.25 until the next node, we say that A will be responsible for that part of the circle. So that means that A will store alpha, and B is responsible for the part until the next node. So B will store beta and delta. So that tells us where each data item is ultimately going to be stored. And then the advantage of doing it this way, rather than just randomly, or rather than just deterministically mapping each data item to a node, is that suppose a third node joins, which ends up being, say, there. So this new node joins. Now B is only responsible for this part, or C. B is only responsible for this part, and C is responsible for that. So that minimizes the amount of movement that needs to happen. If we were to just store the first third of the first half of the values on A, the first half on B, then when C joins, everyone else needs to shift a bunch of things. This minimizes the amount of data that needs to be moved when network churn happens. So that's the first part. How do we store data on the nodes? The second part, of course, is how do we, given some node, find the node that actually has the data you're looking for. And the details of this are a bit more complicated than I want to go through here. Also, I don't fully remember them. But the idea here is that C will have, and C's position is, say, 0.7. C will have a pointer straight across the circle, and then the next node after that. So 0.7 plus 0.5. C will have a pointer to 0.3. And actually, that'll be the first node that's after 0.3. So C will have a pointer to B. And then it'll also have a pointer that is halfway around the circle, and a pointer that is a quarter of the way, and an eighth of the way, so on, logarithmically spaced like that. So in order to find a particular value, say C wants to look up the value that has the hash that puts it there, then it will ask the last pointer that it has before that, and then that one will in turn ask the last pointer that it has before that, and you'll eventually get to the node that stores the data in a logarithmic number of steps. So that's core. That gives us a way for multiple nodes to work together to store data. It is scalable, distributed, and it can be a database depending on how you implement. That's an implementation detail, really, whether it gives good abstractions for that or not. But the issue is that it does not trust this. We have no defense here against, say, C being lazy and following the protocol perfectly, except it doesn't actually store any of the files, and when you ask it for one, it just doesn't answer. So that's the first big concept I wanted to go through. And now I want to stop again and ask for questions.
Quick question, what happens if one of them fails? Like one.
If one of them fails, then, so I've simplified it a bit. There's actually there is some replication in this, in like a practical implementation of Chord. Like it's not just so say this is our circle and our nodes are instead of just storing the interval to them, they might store the next three, and that one will store the next three from there, and so on. So that if any single node fails, it can be recovered.
So just to clarify, the efficiency then is O1 on insert, but log n on reading? Or
On insert of, it'll still be logarithmic on insertion because you have to find the node that it should be inserted at.
okay.
So again, we're not actually using Chord specifically. We're not far enough to have implemented. This is the multi-swarm stage that this comes into play. But we're not planning to use Chord specifically. We're planning to use Kademlia, which is a similar concept but with a different underlying implementation. Kademlia has a lot of caching and gives advantages. If you frequently look at particular data, then your cache naturally will get you basically constant time access to data that you've looked at recently.
What is the algorithm you said that you use?
Kademlia?
Kademlia.
Again, that could change. We haven't gotten as far as actually implementing it, but currently that's the plan.
So is there a verification process for when it's safe to each node? Like how do we get a status when everything has been saved with that node? Can I get my question?
I don't believe Cord actually gives good guarantees about, and maybe just not remembering this, but I don't think Cord really addresses that problem. It may be done in a best effort way.
So we're not sure if that data.
Like there may not be a
Yeah.
data is committed now. It's definitely safe. But again, there may be. I just may not be remembering. Okay. So I'm going to leave some of that to try and remind to make it not be memorable. Secondly, I want to talk about blockchains in the abstract. So let's think about Bitcoin because it's the classic. And most people, I'm going to guess, reasonably think about Bitcoin as a currency. It is this good that exists. I can send it to someone else, and then because I sent it to Joe, I can't also send it to Alice. And that's what it is. But in order to do that, what Bitcoin is a ledger of transactions. We've got some So we've got blocks, and then each block contains many transactions. But if we generalize this a bit, these aren't just transactions, these are really arbitrary pieces of data that can be included into the blockchain or not based on some set of universally agreed rules. In the case of Bitcoin and transactions, those rules are you have this coin and you haven't given it to someone else in the meantime. But we could define anything else to be the rules for what data elements are included. With Ethereum, we generalize that to transactions operating on some replicated state machine, for example. So if we see this as a ledger of arbitrary data elements subject to some common rules for inclusion, then that starts to sound suspiciously like a database. We can use it to store, if we define a blockchain for some particular purpose, we can use it to store any type of data in a way that is resistant to bad actors and is universally available. So we get a trustless architecture, we get a distributed architecture. No single Bitcoin miner needs to continue to exist for the network to keep happening. And from the ground up, it's designed such that bad actors can't even prevent it from occurring, much less corrupt its operation. But it is, and we can give a database-like interface to data stored on a blockchain as well, but it's very bad for scalability. All of the classic Bitcoin, Ethereum, and any other blockchain that hasn't done a lot of theoretic work to defeat this problem process a constant number of transactions per block, regardless of how many nodes are added to the network. In fact, adding more nodes to the network just increases the overhead without increasing the amount of computation that can be done. So, our core goal is to combine these two concepts. Because this one gives us all the things that we want, except it's not trustless. And this gives us all the things that we want, except that it's not scalable. So, our problem with Cord was that we couldn't trust a node to do what we said it would. We can trust a blockchain to do what we say it does. We can trust a blockchain to do what we say it does, but a single blockchain can only process a constant amount of data. Well, it's fine for a single node in Cord to only process a constant amount of data. So instead of having this circle of nodes, what if we had this circle of little networks? What if if we had this circle of little networks, we said that this blockchain was responsible for all the data between it and the next one, this for that, and this for that, and so on. And that gives us reliable operation of nodes in a distributed hash table, essentially. And to be clear, the distributed hash table we're using is not Cord, and the individual nodes here are not actually running a blockchain. We're doing something that gives the same semantics by a consensus algorithm, which is similar to what Neo does, if you're familiar with that. But the concept is that, so this is our metaswarm. We call each of these subgroups a swarm, which is responsible for storing some portion of the data. And then the swarm collectively stores an arbitrary amount of data that scales as you add more nodes to it. So that is the end of my prepared remarks. Please ask questions.
Do you have any sort of specification in regard to nodes that want to join the swarm?
Not yet. That is a difficult question from a theoretic point of view, because, for example, if you consider, so suppose that the incentive here was proof of work or proof of stake or so on to prevent a single node from behaving badly. The problem is that those are secured by, well, you have to have more than half of the power of the total network in order to defeat it. But if this is its own blockchain, then you only have to have 51% of the power of this swarm to corrupt that swarm, and that means an adversary could corrupt an individual swarm without actually having the majority of the network power by simply targeting that swarm and focusing all their resources there. The question of how we prevent that from happening basically boils down to you don't get to choose what swarm you're in. The network decides for you what swarm you're in, and it's a difficult theoretic question that is several steps down our roadmap.
So for the scalability issue, each individual swarm will have its own scale at which it can operate, but if I need to expand the network to handle more transactions, I can simply add another swarm to it to scale.
Yeah. The size of an individual swarm will be chosen to give a certain probabilistic guarantee against an adversary having more than enough of it to disrupt its consensus. And I forget how exactly that math works. But the size of a single swarm will either be constant or a slow-growing function of the size of the network. It scales by adding more swarms.
How do you get data from each of those little networks?
So the simplest answer is that you do the same thing as you did in Cord. So in Cord, you asked this node, and either it had the data itself, or it said, I know this other node that has the data itself, and you asked that node, and after a logarithmic number of steps, you would get to the node that had the data, and then you would get the data. When we move to here, it's no longer quite that simple, because this isn't a single node you can talk to, and there's no individual node in here that you can trust. And so the simplest answer is, okay, well, I'll just ask all of them. And what I'm asking is, do you have this data, or do you know someone that does? And none of them can productively lie, because if they don't have the data, they can't forge the data because it's cryptographically signed. And if they try to, if they know someone that has the data, but they choose not to tell us, then that accomplishes nothing, because an honest node will tell us. And if they give us a useless pointer, then we'll probably follow it for a couple hops, but we'll still find the data from one of the nodes who told us the honest answer. So we just ask all of the nodes here, and we take the union of the answers they give us, and then we do the same thing as we would do in Cord. And we can make optimizations between, instead of asking all of them, we ask some subset with, like, it's a probabilistic trade-off.
So you're just saying this is not what you guys have right now, right?
Correct. What we have right now is most of one of these. We are, well, I mean, think of it as the trivial case where there is only a single swarm, and so it's responsible for the whole circle. Because you don't have to do any logic to figure out which swarm is responsible for a node, because it's always the same one.
Do you guarantee that you have enough node in the swarm to operate?
Economic incentives. So all of the payments are based on all of the payments are based on the Bluzelle network token. And if there aren't enough nodes in the swarm, then the price that a node could, well, so nodes in the network versus nodes in the swarm are different questions. As for a single swarm having enough nodes to be reliable, that's the question to the part that decides what node or what swarm a single node is in. That has to reliably, like it'll probably be probabilistic. We'll show that with the academic term is with approximately 0 probability, swarm will not be large enough. So yeah, that's responsible for making sure that each swarm is large enough. As for the network as a whole having enough nodes, that is where the economic incentive comes in. If there aren't enough nodes, then the price that a node could expect to earn rises and so on until there are enough nodes.
Like, in my view, I think your implementation of like multi-swarm database is really similar to the BGP protocol.
I am not familiar with how BGP
Oh,
works.
so it's just like a, what is it? A border gateway protocol.
A what?
Border gateway.
Oh, BGP.
Yeah, BGP.
Yeah.
So essentially, you have like different ASs instead of like swarms, and then you can have like those ASs talk to each other to determine the number of hops and the most optimal sort of path to access a certain data stream.
So we're not doing any routing. There's no question of, if I know what node I want to talk to, the assumption is that I'm talking to it over the internet, and the layout in distributed hash table is unrelated to the geographic layout. So the assumption is that if I already know what node I want to talk to, then I just talk to it directly. The question of like figuring out how to get to a node is just figuring out what that node's identifier is.
But the problem is, yeah, but when we have like a piece of data, right? So you don't know which node does it belong to.
Yes.
So ideally we would ask like one of the nodes and then have that node propagate the question throughout the network.
We want to avoid propagating it through the entire network because that doesn't scale.
I mean, finding like whatever data, like which node has your data, which
Yes.
swarm has your data.
Yes. So what is the question?
So just comment.
It's been a while since I took networking. I don't remember
Okay.
very much about BGP off the top of my head. I thought you said PGP at first, which is also a thing that could be drawn with a diagram involving a network.
Quick question, what was chords? Not familiar.
Could you speak up?
What was chords? You mentioned it.
Yeah, chord is this algorithm that I described here. It's a distributed hash table.
Is it an acronym?
I don't remember. I mean, the idea of a line across, like, the geometric term for a line across a circle is a chord. I don't know whether it's also a contrived acronym or not.
Can you speak for how the BNT, like internal token, will work with such implementation in the network?
We'll work with what?
Like this kind of a method of the Oracle and how it's gonna be implemented into systems.
Sorry, is your question how the BNT, like the Bluzelle token, works in the
No, the BNT, the internal token.
The internal token, how does that, you were asking how does the BNT come into play here?
Yes.
In this solution?
So the idea is that to incentivize the proper behavior of the miners every time one of these nodes does what it's supposed to. That is, every time you ask it for some data and it returns, every time you ask it a routing request and it returns an answer, it gets a small payment in BNT. And also, for the storage of data itself, the network can occasionally demand a proof of storage from nodes that are supposedly storing data and pay them if they, so by proof of storage, I mean, there are efficient protocols for how you would demonstrate that you have a piece of data without actually having to transmit it over the network. Suppose it's very large.
So you're developing like a consensus algorithm inside?
Yeah, I mean, each of these are a consensus algorithm.
What's the relationship between the BNT and the BLZ?
That's an open question.
How do you mean?
I mean, it's kind of in flux, last I heard, we're not exactly sure. I mean, the current plan is that the BLZ is the token on Ethereum that represents, like, partly, like, is investment in Bluzelle's company, but also will be used to purchase Bluzelle services when that's a thing you can do. But Ethereum is way too slow and expensive to use for all of these little microtransactions, so that's what BNT is for.
So would BLZ basically be like a securities token?
What?
Would it be like a securities token then?
I'm not sure what you mean by that.
Like, is there like any stake in the company that BLZ represents?
I believe so, I'm not.
It's basically, he's asking if it comes under regulatory regulations, basically.
I believe no.
Well,
Eric,
it's a
do you wanna
utility
comment?
token, right? You're purchasing access to the database with BLZ.
But it's
No, it's
also,
like BNT is for access to the database, right?
Well, BLZ is internal, so you're exchanging that for BLZ.
Oh yeah.
but I thought it was the other way around.
It's
sorry.
It's bidirectional.
So,
Yeah, so-
Bluzelle's a utility token, I mean, strictly speaking,
Can you speak up?
oh, not speaking as a legal expert, but it's a utility token, it's not considered a security. So, it's the short answer.
But we have the BNT internally and the BLZ externally. The reason for that was because of the fluctuation in token prices, that kind of thing. And we wanted to facilitate a more stable tokenomics internally because we're doing so many microtransactions that we can't bank on the fluctuation in prices of tokens and
Even
stuff.
without the fluctuation, just the transaction fee on a single Ethereum transaction is way more than our individual payments are going to be, so it wouldn't work.
Yeah. It's insulation, yeah. Or buffer.
Yeah, the Ethereum network is just not suitable for the level of transactions we're doing. It's a problem that most decentralized services share. I mean, if you're looking at, Gnosis or Uport or any kind of service that's decentralized, their ERC20 token is usually backed by a auxiliary token on their own native network.
And the reason we want to use the Ethereum token in the first place is that there's a lot of buy-in to Ethereum already. It's easy to get Ethereum to pay us in that, but we can't actually use it for our little payments internal to the service because it's just too expensive. Too high overhead, I should say.
Is it very fixed then between the internal and the BNT?
I think that part. He's asking if the parity is fixed between the internal and BLZ.
They're one-to-one.
They're one-to-one.
They're one-to-one, the two tokens are equal to each other. BNT and BLZ, right, that's the question?
Yeah.
Yep, they're mapped one-to-one.
Are they interchangeable? Did I miss that?
Yeah, we're gonna have a gateway between the two, so that if you want to convert BLZ to BNT, you can do that, and they map one-to-one, that's right.
And I think, I can't remember if it was both for the people using the database service as well as those who are offering their computers for storage, but both parties have to have a stake in they both have to have a bank of BNT before they can participate in the solution, correct?
Right, if you're trying to run a node as a producer, you have to have a stake. If you want to use the database as a consumer, you have to have minimum tokens in there.
Yeah.
You're kind of putting them in escrow so that you're able to use the services.
So it's like just staking like Masternodes or something.
Yeah, I mean, I wouldn't call it staking if you're using the database as a consumer. It's more of just having prepaying a certain amount ahead of time because it just makes performance faster. We're not going to basically we're not, the model is we're not going to be charging you every time you do a read or write because that's just very high overhead on the transaction log. So what we do is we just make sure you have a certain amount of tokens ahead of time so that you can perform your transactions fast.
I think that a lot of folks here are familiar with IPFS. Isabel, how would you compare or contrast us against them?
IPFS is not really trustless, for one. There's no, so IPFS is, I would compare to BitTorrent, is a good way to transfer files. It is not a good way to store files. If you want to put if you want to, air quotes, put something on IPFS, then the problem is that every other node can choose to cache that or not. And if you're not storing it yourself, you have no guarantee that it'll be persistent. It doesn't really attempt to solve the same problem as we are.
Any more questions?
How do you join the network today? Is that open?
Today you don't. We don't, so our consensus protocol running in this little box does not today support nodes joining or leaving at all. They all know what all the nodes are when they start. So in order to add a node, we go to that configuration file and tell them all that there's a new node and restart them.
So where are those nodes today? You guys.
There are a bunch of nodes in Azure.
Yeah, gentleman over there with the beard and the glasses, Andrew.
Yeah, so we are running just within a Docker swarm, not a Bluzelle swarm, within Azure. So there's just a bunch of instances that are stood up that are running our latest and greatest code. And again, it's all pre-configured. We build out configuration files. A bunch of folks in the room have actually built out their own locally running swarms, but these swarms are not connected to each other. There's no interconnection, as Isabel has drawn on the board.
Yeah, creating one of these little swarms is a bit of a complex problem in itself, because it's kind of its own ecosystem, right? Who's the leader? How do you handle bad actors, good actors? How do you reward bad actors, good actors? How do you handle when somebody doubles the load? How do you handle when the load goes down? How do you handle when somebody unplugs their laptop by mistake? How do you handle when a new one joins? So there are quite a few questions to be asked, and the Docker implementation we've done is a pretty good proof of concept that we're on the right track. The science is there, and we've implemented it properly with brilliant folks like Isabel, Neeraj, Andrew, and the other guys, Monty, John, whoever not named, Rich, wherever you are, Rich.
You have to name everyone in the room.
Yeah, and Mehdi, sorry, Mehdi.
Is it in one specific zone in Azure?
Yeah, right now we're just running there. It's West 2, I believe. And again, that was just arbitrary. So, I mean, today we could stand up a multi-host swarm as well. We just chose not to due to complexity of configuration.
If you guys want to, community, have you had a chance to check out the instructions in Slack for doing that?
No.
Okay. He wrote that. Okay.
Yeah, I can remember the video that went up in July.
Sure.
Yeah. Some great questions. Anybody else have anything else? No? Cool. Well, let's have a round of applause for. Oh, is there a hand back there?
Just a quick question. So, the CRUD app that you can install using the JS library, is that a local swarm then?
The question is the CRUD app you can install using the JS library a local swarm? No, it is not. What that is it's in, so you know how I said that you talk to this swarm and it tells you either I have the data or this other swarm has the data or so on? And then you have to say talk to that one and then download the data. This is what our library does. And then your client talks to that library, says just get me the data. The library does all those lookups, gets the data. The CRUD app is just an example client of this library.
Yeah, Monty built JavaScript, the library, as well as the example application to connect to this. Is that accurate? I see heads nodding. Good. So if you wanted to do something like that, we would encourage it also. We chose JavaScript, but there's other languages out there, or even other platforms too. You could have a library to interface. I think I was even talking to some of the guys here. I can't remember who I was talking to. But you could have a library to interface to other platforms out there, other blockchain platforms, that kind of thing. Sorry, see your hand. Yes?
Yeah, so the local, okay, sorry. Because like I installed it onto React Native and I can add data to the database, so I'm just wondering where the database is. And I can see it reflected in the CRUD app.
Are you connecting to one of our swarms, or did you run your own swarm?
That's what I'm wondering. Did I actually run the swarm on my machine?
Did you You install Docker.
Yes. But never mind, I was just asking what
I'll come sit with you as well and we can figure it out, yeah.
Because I'm just wondering where the data is actually stored, so.
Okay.
And whether or not I'm actually connected.
Okay, you guys can troubleshoot that and figure that out later.
We do have a status database within
Sorry, I hear a voice, but I don't see lips moving, and I can't see anybody talking.
I
Who's
was
that?
asking about, should we install Docker right here?
Who's asking? When?
So
Oh,
in order to run our own database, so we have to install like a localhost database, we have to install Docker. And then have that JS header connected.
The only reason that you have to install the only reason that I think, unless someone's doing something that I haven't thought of, the only reason you would have to install Docker and run your own database is out of curiosity. If you just want to use the database, then you can use this library and point to one of our existing swarms.
Okay, so we can't point to localhost to that.
You can point to localhost if you want to.
But our localhost doesn't have a library access. I mean, it doesn't have a database.
Well, you could run one.
Then that's why you need a Docker to run.
Yeah.
Oh, okay, in that case. I mean, that's what a lot of like confusion with like, how people are not connecting to databases. Because everyone just thought, oh, it's fucking localhost and then magically a database slots.
I think that's something we'll have to take note of to better clarify
Yeah.
for people to understand how to implement the solution and use it. Thanks, Wen.
No problem.
Any other questions? Okay, great. Well, that was Isabel's presentation today. Thank you so much.